Welcome all. So this is the first lecture on practice questions on theory of machines, that is TOM-1. So I'll be bringing some more lectures on theory of machines with some very good quality questions, and I'm actually planning to take some questions from different foreign author books. Actually, in this session, I have taken these questions from Mariam and Craig. Okay, chalo. Now, let's take the first question. It is the basic question. Just basic question. Let's see. It's not on flywheel. Don't think that it is a question on flywheel. It is not on flywheel, but it is on basic concepts. A flywheel rotating freely at 1800 rpm clockwise. Note down this. Clockwise. Okay. Now, 1 second, please. Right. Is subjected to a counterclockwise variable torque. Is subjected to a variable counterclockwise torque which is first applied at time t is equal to 0. Actually, flywheel is initially rotating at 1800 rpm in clockwise direction. So an opposite torque is applied, and moreover it is a variable torque. So when is that applied? When we started the experiment, the time t is 0. At that time, the flywheel was rotating at 1800 rpm clockwise. Okay. The torque produces a counterclockwise angular acceleration of 40 radian per second square. The angular acceleration is alpha, which is 4t. It is variable, where t is the time in seconds during which the torque is applied. Okay. Now, first question, the time required for the flywheel to reduce its speed, to reduce its clockwise angular speed to 900 rpm. क्या question है sir? Initially it was rotating at 1800 rpm clockwise, so a counterclockwise torque is applied so that definitely the speed gets reduced. So he is asking in how much time the speed gets reduced from 1800 rpm to 900 rpm. That is the first question. Second, the time required for the flywheel to reverse its direction of rotation. It means originally it was rotating in clockwise direction. At what you have applied a variable torque in counterclockwise direction, so definitely its speed gets reduced, and at some point of time the speed will be 0. He is asking, and the speed is 0, and because of that counterclockwise torque, and it may start rotating in anti-clockwise direction. He is asking at what time it reverses its direction. Means indirectly he is asking at what point of time the speed is 0. And the third, the total number of revolutions clockwise plus counterclockwise turned by the flywheel during first 4 seconds of torque application. I repeat, please try to understand the question neatly. Initially the flywheel was rotating at 1400 rpm clockwise. So a counterclockwise torque is applied, and he has given the angular acceleration as 4t, where t is in second and alpha is given in radian per second square. So what is happening when you apply that counterclockwise torque? The speed starts reducing. So the first question he asked is, in how much time the speed is reduced from 1800 to 900? First question. Second, at what time the speed is reversed? Means he's asking when is that speed becoming 0. See, if the speed is to be reversed from clockwise to anti-clockwise, it should become 0. Then only it changes its sign. Okay. And the third one is total number of revolutions, that is clockwise plus anti-clockwise, in the first 14 seconds of application of this torque. Very good. A wonderful question, sirs. Let's try to solve this question. Alpha is given as 40 radian per second square. Okay. And the initial speed is 1800 rpm. But please note down that it is clockwise. Generally, our convention is clockwise rotations we take it as a negative and anti-clockwise we take it as positive. Chalo, first I convert this speed into radian per second. Omega is 2 pi n by 60. So therefore, the initial speed is 2 pi n1. What is n1? 1800 by 60. So 61, 60, 30s. So it is omega 1 is equal to 30 into 2 is 60. It is 60 pi unit radian per second. Very good. But I take it as minus. What is the reason for taking this as minus? Because it is clockwise. Because we have the convention of taking clockwise and anti-clockwise. Okay. Now, देखो sir. The angular produces counterclockwise angular acceleration. So should I take the counterclockwise positive? Yes, sir. Clockwise is negative, anticlockwise is positive. Okay. Now, how to start this question? So what I say is, first try to construct the equation between angular velocity omega and time t. If that is established, to some extent, the problem is solved. So what is the relationship between omega and time? Including alpha, because alpha is given. Just think carefully. How can I bring the relationship between omega and time by including alpha? Because alpha is given. मैं सोचा angular acceleration is given by rate of change of angular velocity. I know this. Very good, sir. So d omega is equal to alpha dt. ठीक है, sir. Or d omega is equal to alpha is given as 40 into dt. Correct, sir. Integrate this equation. Okay. Now you integrate. So what do I get? Integral d omega is omega. And here, what is x dx? X square by 2. For t dt is t square by 2. But already there is 4. So therefore, 4 by 2 is 2. So this will be 2t square plus some integration constant. So how do I establish the integration constant? Clearly he said initially at a time t is equal to 0, the speed is omega 1, which is minus 60. What is the reason for taking minus? Because minus indicates clockwise and plus indicates anti-clockwise. So put karo, when t is 0, when t is 0, my omega is minus 60 pi. And t is 0. So 2 into 0 square plus c. So this will be 0 and c is equal to minus 60 pi. Wonderful, sirs. So omega can be written as 2t square plus c. 2t square plus c. But what is c? Minus 60 pi. So minus 60 pi. So therefore 2t square minus 60 pi. Please note down that here, this is in radian per second. If you get the value as positive omega, it is anti-clockwise. If you get the value as negative, it is clockwise. Now see the question properly. He is asking, at what time the speed is becoming 900 clockwise? So originally it was rotating at 1800 clockwise. Now after some time, the speed is getting reduced because of the counterclockwise torque. So let us see what is that 900 RPM. Omega is equal to 2 pi and n is 900 by 60. So you will get the value of omega as ये कितना है sir? So I think it is 200 gone, 15,690. So it is 30 pi radian per second. But please note down that it should be minus. What is the reason for taking minus? Because you just see the question, it is clockwise 900. Clockwise 900. So let us put it here. So we are trying to find out at what time the speed is 900 RPM. But 900 RPM is nothing but 30 pi radian per second. Put the value here. So omega is minus 30 pi. So 2t square minus 60 pi. Wonderful, sir. So just I am calculating the time when the speed is becoming 900 RPM. Bring this 60 to the side. 60 minus 30 is 30 pi is equal to 2t square. So therefore, it is 15 pi is equal to t square and t will be equal to under root of 15 pi, that will be in second. Let me check, sir. What is root 15 pi? We are getting this time as 6.86 second. Wonderful, sir. So this is the fundamental question, my dear students. This is the fundamental question. He is just checking your basics. But fundamentals are very, very important. So we found K. From the beginning, when the speed was 1800, it is taking 6.86 seconds to reach 900 RPM. Wonderful. Now, if you observe this equation carefully, omega is 2t square minus 60 pi. I will take this equation, the relationship between omega and t. Omega is 2t square minus 60 pi. Omega is 2t square minus 60 pi. Let me check, is it correct? Omega is 2t square minus 60 pi. Exactly. This is in radian per second. Okay, sir. Now, what is he saying? At what time it is reversing the direction of rotation? You know, you are going like this in the positive x direction. So when can you reverse? When your velocity becomes zero, then you reverse. It's something like this. You are throwing a ball. So when you are throwing, its velocity is decreasing, decreasing, decreasing. The velocity is in the upward direction. At some point of time, the velocity becomes zero, then you reverse. So the meaning here of reversing the direction is, he is asking the time when it is when its speed is becoming zero. This omega is 0 is equal to 2t square minus 60 pi. So therefore, 2t square is equal to 60 pi and t square is equal to 30 pi. So t will be equal to root of 30 pi. So this time is given in second. So 30 into this, it is 9.71 second. So what does it mean? From the beginning, when you started, when the speed was 1800 rpm, so to reach 600 like when initially the speed was 1800 rpm, from 1800 rpm to 900 rpm, it is taking 6.86 seconds. Already we have calculated the first part. The second part is, so when is it reversing the direction? When the speed is becoming zero. It means from the beginning when t is 0 to 9.71 second. At 9.71 second, its speed is becoming 0. At that time, it is changing speed. So let me try to plot a graph between omega and time t. Okay, sir. Okay. What was the initial speed? Understand carefully. If you see this graph, it's very clear. It is parabolic. It is something like y is equal to x square. Yes, sir. So initially when omega was 1800 rpm, what does 1800 rpm mean? So I am taking omega below because it was negative, because clockwise means negative. So what was the initial speed? It is minus 60 pi. So it is 60 pi. Of course, minus. Okay, sir. And it is reaching 30 pi. Okay, sir. Then it is becoming 0. This is 0. Okay. And it is something like this. ठीक है सर. अब देखो, omega is becoming 0 at what time? Now please understand carefully. This omega is becoming 0 and you know this time is 9.71 second. ठीक है सर. At what time, my dear students, the speed is becoming 900 rpm. This is 900. Arey yaar, this is in radian per second. 60 pi is nothing but 1800 rpm. Why are you taking to the on the negative axis? Because it is clockwise. ठीक है. And this is your 900 rpm. ठीक है, sir. So how much time it has taken, sir? I think we have calculated. This time is 6.86, something like this. I have seen 6.86. Absolutely fine. ये हो गया, sir. Up to this, there is no problem at all. There is no problem at all. First two parts are over. Now let us take the third part. Look at the first part, the time required by the flywheel to reduce its clockwise angular velocity to 900. So it took 6.86 seconds. And the second, the time required for the flywheel to reverse its direction, and it is कितना हुआ सर? 9.71 सेकेंड. एंड द थर्ड, the total number of revolutions clockwise and anti-clockwise, counterclockwise, turned by the flywheel in the first 14 seconds of torque application. Now stop. This is your clockwise rotation, omega is negative, and this is your counterclockwise rotation, omega is positive. In how much time he is asking? 14 seconds. So already this is 9.71. Let us take this as some 14 seconds. ठीक है सर, 14 seconds. So during these 14 seconds, these are clockwise rotations, these are anti-clockwise, because anti-clockwise means positive. He is asking the total rotations executed by the flywheel in the first 14 seconds. कैसा करेंगे सर? सोचो एक बार. Just you think, how can we proceed? मुझे लग रहा है रोटेशन का मतलब, एक बार सोचो सर, you just think, rotation means theta. Rotation is theta. Yes sir. How to link between time and theta? Have a relationship for omega. देखो, omega is 2t square minus 60t. Omega is 2t square minus 60 pi. Let me check. Omega is 2t square minus 60 pi. है सर. Rotation का मतलब, he is asking in 14 seconds. How to link rotation means theta, time, there is a relationship between time and omega. क्या ऐसा नहीं सोच सकते सर? Omega is given by d theta by dt. Rate of change of angle is nothing but omega. Rate of change of angular displacement is omega. Yes sir. So can I write this as d theta is equal to omega dt? Yes sir. Already omega equation is known. So d theta is equal to omega. What is omega? 2t square minus 60 pi. क्या हो रहा है ये? क्या सही नहीं लिख रहा. Omega into dt. Yes sir. So let us calculate theta. But please note down that this is in radian. This is in second. So omega is in radian per second. This theta will be in radian. लेकिन वो rotation पूछा है sir. हाँ, we can do it. So there is no problem. Because how to अरे theta आ गया तो खत्म है sir. Theta will be in radian. Later I will convert radian to rotation. Don't worry about that. वो मैं कर लूंगा. लेकिन अब देखो sir. यहाँ पे मैं क्या करूंगा ना? If you see the graph properly, it's like this. So this is 9.7 second. I will try to, because this is one type of rotation, that is all clockwise. I will try to find out how many rotations, that is clockwise rotations, it is making from time t is equal to 0 to 9.71. उसके बाद क्या करूंगा? He has asked in 14 second. Then I will integrate from 9.71 to 14. This will give me clockwise, anti-clockwise. This will give me clockwise. Sir, समझ में आ गया sir. So I will split this into two. So I will get the total rotations. ठीक है sir. ध्यान से सुनो. Let me integrate this. कहां से? So this is the fundamental equation, my dear students. Very good. बहुत बढ़िया. Don't worry. Now, this is the fundamental equation. अब देखो, what I'll take this equation. This is the general equation. Okay. First, I'll take this equation and integrate from 0 to 9.71, because from 0 to 9.71 it is clockwise, one nature. From 9.71 to 14 it is another type. Okay. So first I'll get clockwise rotations, then I'll get anti-clockwise. इसको integrate करो. लेकिन this is the equation I am supposed to use for both. चलो. d theta is equal to 2t square minus 60 pi Now let me integrate. Be careful sir, कहां से limits? Initially अभी start हुआ, अभी rotation शुरू नहीं हुआ. Yes. Then I'll write some theta1. So what will this give? Total number of rotations from initially I started, अभी शुरू में चल रहा है, तो मैं जब मैं start किया I take 0, then it's rotating, so total rotations I'll take theta1. So can anyone tell what will this theta1 give? It is the total clockwise rotations, because I am taking from 0 to 9.71. Yes sir. So initially time t is 0, तो रोटेशन अभी स्टार्ट नहीं हुआ, मैं अरे चल रहा है लेकिन मेरे लिए अभी रोटेशन एक भी नहीं हुआ ना स्टार्टिंग में. देन इट्स गोइंग ऑन. सो फ्रॉम 0 to 9.7 सेकंड, व्हाट आर द क्लॉकवाइज रोटेशंस? ठीक है सर. इंटीग्रल डी थीटा इज थीटा 1 माइनस 0, दिस विल गिव मी थीटा 1, एंड इंटीग्रेट करो एंड यू हैव डी थीटा. कहां से? इधर देखो, ये डी थीटा तो भूल ही गए. हाँ, नाउ व्हाट इज टी स्क्वायर डी टी? टी क्यूब बाई 3 माइनस 60 पाई, ये तो कांस्टेंट है. व्हाट इज इंटीग्रल डी टी? टी अब पुट करना सर. टाइम इज 0 to 9.71 सेकेंड. सो थीटा 1 इज इक्वल टू 2 बाई 3 इंटू 9.71 होल क्यूब अपर लिमिट माइनस 60 पाई इंटू 9.71. okay, lower limit is 0 0. T is 0, lower limit has no significance. This is the answer. So let me see how much is the value of theta 1. Let me calculate sir. 9.71, अरे यार फटाफट, 9.71 whole cube into 2 divided by 3. This is, एक बार मैं दोबारा कैलकुलेट करता हूँ. 9.71 power 3 into 2 by 3. This is 610.33 minus 60 into pi into 9.71. ये आ रहा है 1830.3. 610.33. This is coming out to be 1220 unit. बताओ सर. Theta is in radian. But मेरे प्यारे दोस्तों, I am getting this value as negative. Can you tell me what is the significance of negative? Clockwise. Okay. Can I convert this radian into rotation? माइनस को भूल जाओ सर. ही इज आस्किंग टोटल नंबर. ही इज आस्किंग टोटल क्लॉकवाइज, टोटल एंटी क्लॉकवाइज. माइनस तो आ गया. माइनस इंडिकेट्स क्लॉकवाइज. ठीक है, एज पर आवर कन्वेंशन. सो आई गॉट थीटा एज माइनस 1220 रेडियन. नाउ अब देखना सर, मुझे पता है सर 180 डिग्री करस्पॉन्ड्स टू पाई रेडियन. ठीक है सर. व्हाट डज 180 डिग्री? देखो 180 डिग्री करस्पॉन्ड टू, इट इज हाफ अ रोटेशन. इट इज हाफ रोटेशन. अनदर 180 करस्पॉन्ड्स टू फुल रोटेशन. सो please note on that 180 degree means half rotation is corresponding to pi radian. 180 degree means half rotation is pi radian. So I want 1220 radian is corresponding to how many rotations? How many rotations? So it will be 1220 into half pi. तो ये आ रहा है, let me check sir. Divided by 2 divided by pi, and this is 194.2 rotations, but this is minus, these are clockwise rotations. Hope you understood. 194 point something sir, 194 point something. Clear है sir? बहुत बढ़िया. चलो अब next, क्या मतलब है sir? See, originally it was rotating at 1800 rpm. It was making in 1 second, in 1 minute rotation per minute. So it was making 1800 rotations per minute. But the speed is continuously decreasing because of the counterclockwise torque. So therefore we could calculate. कभी भी variable है तो differentiation and integration is helpful. चलो next is what? देखो same equation sir. Next is what? So what I do is इसको मैं हटा दूंगा sir. Let me remove this. देखिए अब क्या करेंगे? नाउ आई वांट द सेकंड केस, सो इसको इंटीग्रेट करेंगे सर। डी थीटा इज इक्वल टू 2t² माइनस 60 पाई इंटू डी टी। इसको इंटीग्रेट करो, कहां से? नाउ आई विल कैलकुलेट। सो अब स्पीड जीरो होगा, जीरो से काउंटर क्लॉकवाइज, जीरो से काउंटर क्लॉकवाइज T2। लेकिन जीरो कब रीच हुआ? It reached zero speed at what time? 9.71. So therefore, it reached zero at 9.71 and then up to 14 seconds. This is all the history of counterclockwise rotation. You have not understood. Let me explain again. I am separately calculating clockwise rotations. I am separately calculating anti-clockwise rotations. So 0 to theta 1 is all clockwise, 0 to theta 2 is anti-clockwise. So from, because this is giving from time t is equal to 0, तो ये t is equal to 0 से दे रहा है, इसलिए I have to integrate from, यहाँ पे 0 put मत करो sir, because the speed is becoming 0, clockwise कहाँ, anti-clockwise is starting from 9.71 second, so he is asking up initial 14 seconds. Okay, now integral d theta is theta, so theta 2 minus 1 is theta 2 is again 2t cube by 3. I repeat, t square dt is t cube by 3 minus 60 pi integral dt is t. Now limits are 9.71 to 14. So theta 2 will be equal to, actually you should get this value positive. If you are not getting positive means you have committed mistakes somewhere, because already clockwise you have calculated. This should be anti-clockwise. Let me check. 2 by 3. The upper limit is 14 cube and the lower limit is 9.71 cube. ठीक है, minus 60 pi. The upper limit is 14 and the lower limit is 9.71. Let me calculate, sirs. Let me calculate. 14 cube minus 9.71 cube into 2 by 3. This is 1219 minus 14 minus 9.71 into 60 into, this is 8.6, so 1219, ये आ रहा है 410.35. theta is in radian. Yes, I got positive. This is all anti-clockwise rotations, but I have to convert from radian to rotation. 180 degree का मतलब pi radian. What does 180 degree mean? Half rotation is pi radian. ठीक है सर, तो 410.35 radian is how many rotations? So this will be divided by 2 divided by, ये आ रहा है 65.3. This is 65.3 rotations. Now let us see the total answer. Look at, it is making 194.2 clockwise rotations, 65.3 anti-clockwise rotations. He is asking total. So this will be कितना आ रहा है सर? 259.5. So many revolutions, sir. It's a very good fundamental question, sir. It has opened the eyes of everything. मस्त question था sir, बहुत बढ़िया. Now, without wasting our time, let's move to the next question. हाँ, let us take this. एक काम करते हैं सर, क्या बोला है? हाँ, I'll take this question, sir. हाँ, ये वाला ले लेंगे सर. We'll take this question. Actually, he has given. Please read the question. I'll change the color so that right क्यों आ रहा है? लाल चाहिए. This is given as, please read the question. It's a good question. This is x-axis this is y-axis. ठीक है. Expression for velocity and acceleration. Okay, decreasing at the angular clock. The right angle bar rotates clockwise. See the rotation. This is a good question, sir. Hanji, sir. I'll use vector approach and I'll explain very neatly. Don't worry. The right angle bar, this is the right angle bar. Please listen. This is the right angle bar, sirs. अरे यार पूरा ही गया डायग्राम ही गया सर. अरे यार कहाँ गया. चलो कोई बात नहीं सर. I'll see the question and I'll show you. ये कहाँ गया. गजब है रे ये. I don't know ये disappear क्यों होता है. चलो हमारा किताब तो रेडी है. हमारा किताब तो रेडी है. So why do you worry? It's a good question. Let me take this question. Yeah, this is the question. देखो, let me take the question. The question is this. There is a right angle bar. डिसअपियर हो गया क्या ये. एक बार देखते हैं कहां डिसअपियर हुआ. पता नहीं यार. ओके कोई बात नहीं. There is a right angle bar. सब इरेज कर देंगे. कोई टेंशन की बात नहीं. ठीक है. Don't worry. It's a good question, sir. It's a very good question. In fact. Okay. हाँ. Okay. Now here, this is given as axis. Okay. And here, this is y-axis and this is x-axis. The origin is passing through this. ठीक है sir. This is the origin. ठीक है. This length is given as 0.4 meter. This length is given as 0.3 meter. ठीक है. And this system, ये पूरा एक ही है sir. This is a complete one system. It is complete a single system. एक second. See, I don't have practice on the smart board. ठीक है sir. Okay. This is the system. ये पूरा एक ही system है sir. This is complete single 90-degree member. It's a 90-degree member. ठीक है. And there is, this is point A. ठीक है sir. And what he says is, this system is rotating in clockwise direction. Okay. And the right angle bar rotates clockwise with an angular velocity, and the angular velocity is decreasing at the rate of 4 radian per second square. What does angular velocity decreasing ka matlab? The angular acceleration is in the opposite direction. Then only omega decreases. If omega and alpha increase, they will be in the same direction. But here he clearly gave in the question, the angular velocity is decreasing at the rate of, omega is decreasing at the rate of, what does rate of change of omega? Alpha. So alpha is given. What will be the direction of alpha? It will be in the anti-clockwise direction, and that alpha is given as 4 radian per second square. It is given in the problem. And omega is given as 2 radian per second. Correct, sirs. Okay. What is he asking? Write the vector expressions for the velocity and acceleration at point A. Must question hai sir. Wait. A simple question, but now I'll solve this by using vector approach. देखो, what is this question? There is a 90-degree member. This is the 90-degree member. It is complete a single unit. ये वाला. This is a single unit. This is a single unit. Yes. And the system is rotating in clockwise direction. So at any instant, the omega value is given as 2 radian per second and omega is in clockwise direction. Omega clockwise hai. This omega is decreasing at the rate of 4 radian per second square. मतलब omega decrease का मतलब क्या है sir? The angular acceleration is in opposite direction, anti-clockwise. When both increase, मतलब जब omega बढ़ता है, it means angular acceleration and angular velocity will be in the same direction. Very good, sir. Now he is asking, what is the velocity and acceleration at point A? Now let us solve this question by using vector approach. But he in fact he asked, what is the velocity and acceleration of point A in vector form? ठीक है sir. Very simple question. So this is the origin. मतलब about this point the system is rotating. मैं क्या करता हूं sir? Let us find the position vector of A with respect to origin. जिस point पे घूम रहा है उस point पे let us find the position vector. देखो sir, let's see how the position vector look like. देखो एक बार. Okay, let me change the color. पता नहीं यार, ये आदत नहीं हुआ ना मुझे. हाँ जी सर, देखो. Yes, this is the position vector. Let me try to draw. So from the origin, this is, देखो origin से ये point A कितना दूर पे है सर? Point 0.4 means in the x direction. Let us take the unit vector in the x direction as I cap, positive x direction. And this is the positive y direction. ये मेरा positive y direction. So let us take the unit vector in this direction as j cap. So what will be the position vector of A? The position vector of A is given by, my dear students, what is from the origin, kitna positive x hai re? 0.4. So it is 0.4 I cap. Please, my dear students, from the origin it is to the right side, means positive x direction, because the axis is selected like this. And one more thing, don't think that x and y are always horizontal or vertical. X is horizontal, y no, coordinate axis is your choice. ठीक है सर. अब देखो, now what is y? From the origin ये point ऊपर है सर. कितना ऊपर है? 0.3. Excellent sir. I repeat, from the origin positive, कितना positive है? 0.4. From the origin कितना ऊपर है? How much is up? It's 0.3. ठीक है, it is in meter, no problem. Now can you tell me what is omega vector? Everyone knows. देखो एक बार, it is rotating in the clockwise direction, means it is xy plane. This is xy plane and the rotation is into the screen. देखो, when it is rotating clockwise, it is into the screen. What does into the screen mean? All clockwise rotations I take it as minus. Into the screen. अगर ये I cap है unit vector in this direction, if it is j cap in this direction and perpendicular to this is k cap, so I write this as minus 2 k cap. Why minus? Because it is clockwise. Can you tell me what is alpha? What is alpha? Everyone knows this alpha is counterclockwise with a value of 4. So what is the meaning of this? Counterclockwise is positive, so therefore it is 4k. Very good, sirs. Once you write this, the rest is mechanical procedure. What is he asking in the question? He is asking the velocity and acceleration of this point A. बहुत बढ़िया, sirs. Do you know the omega of this complete system? Omega याद रखना किसी point का नहीं होता है sir. Omega is for the all angular quantities are for a body. For a body, angular quantities will be same. ठीक है sirs. For this complete 90-degree member, the angular velocity is minus 2k. What does minus 2k mean? K means it is rotating about z axis, which is perpendicular to this xy. And what does minus signify? Clockwise. Alpha, K means again it is in anti-clockwise rotation in xy plane, that is about z axis. Z axis is like this, दोनों का perpendicular. It is x, it is y, and z is like this. So बाहर आ रहा है तो plus z, अंदर आ रहा है minus z. Clockwise is inside, therefore it is minus. Clockwise is minus. ठीक है sir. Very good. Now, my dear students, the velocity is given by in vector form. ऑफ कोर्स अगर आप स्केलर वे में कैलकुलेट कर रहे हैं आर ओमेगा, अगर आप वेक्टर के फॉर्म में लिख रहे हैं इट इज ओमेगा क्रॉस आर. डायरेक्टली आई गेट किसका वेलोसिटी चाहिए. इफ यू वांट द वेलोसिटी ऑफ पॉइंट ए, इट शुड बी द पोजीशन वेक्टर ऑफ ए. दैट्स इट, दैट्स इट. नाउ if you want the velocity of A, why are you writing in vector form? Because he only asks write in vector form. Therefore, it is in cross product, the order of multiplication is very important, because R cross omega and omega cross R are not same. But if it is a scalar product, there is no problem, because A cross B scalar में क्या होता है? Scalar AB cos theta. ठीक है, listen carefully now. Omega, this is 𝐼𝐽𝐾 omega. What is omega, sir? देखो omega can be written as 0I plus 0j minus 2k. देखो this is omega. So 0I पहले omega लिखो, 0j then minus 2. ठीक है सर. Then R, what is R? I J, I, J, no K. I think now you can multiply this very easily. So therefore, velocity vector A of A is given by I into, and you know very well, this minus this 0, minus of, यहाँ पे minus है, minus of minus is plus होगा. 0 into 0 is 0, minus of this into this. But already there is minus, minus of minus is plus, means this into this is 0.6. माइनस जे, यू नो वेक्टर मल्टीप्लीकेशन ना, माइनस जे. तो मैं मैट्रिसेस में बताया था एडजॉइंट वाई टू टेक माइनस एम प्लस एन, ऑल दिस आई हैड एक्सप्लेन. तो ये ले लो, तो ये 0 हो जाएगा. माइनस ऑफ माइनस, ये अगेन प्लस. 0.4 इंटू 2 इज 0.8 प्लस 0.8. देखो माइनस जे 0, माइनस ऑफ माइनस इज प्लस, इट इज 0.8. एंड के का क्या है सर? 0 0 प्लस के इंटू k into 0 0. So you will get the velocity of point A as 0.6 I cap minus 0.8 j cap. Let me check, sir, is it correct or not? Let me check. Velocity is 0.6 I cap minus. So can I find the magnitude? Very simple, sir. If you want magnitude, it will be under root of this square plus this square, that is 0.6 square plus 0.8 square. You can easily calculate so many meter per second. Now the question is how to find acceleration. So you may be wondering, sir, generally calculation of acceleration is very lengthy. So in GATE examination, acceleration questions are very rare. True, I agree with you. I agree. अगर मैं इसको सिंपल वे में सॉल्व करूं तो बन सकता सर क्वेश्चन. डोंट थिंक दैट एक्सेलरेशन क्वेश्चंस आर नॉट गिवन इन एग्जामिनेशन. गलत. You have so many questions on Coriolis acceleration. You have so many questions on tangential acceleration. You have so many questions on normal acceleration. बहुत सिंपल. इधर देखो. You know, my dear students, the velocity vector is given by omega cross r. ठीक है सर. If I differentiate this, you have studied in differential calculus. Okay, vector algebra. You differentiate this, what do I get? एक बार देखना सर. तो acceleration has two parts. One is tangential acceleration, one is normal acceleration. So magnitude wise, if I check tangential acceleration, it is r alpha. And magnitude wise, if I see क्या बोलते हैं नॉर्मल एक्सेलरेशन और रेडियल एक्सेलरेशन, ओमेगा स्क्वायर और v स्क्वायर बाय r, समथिंग लाइक दिस. एक सेकेंड बिफोर आई प्रोसीड, एक बार देखना सर, the total acceleration has two components, one is tangential, one is normal. ठीक है सर, the tangential acceleration is given by magnitude wise, अगर हम स्केलर की बात करें r alpha, वेक्टर में लिखता हूं सर, and the normal acceleration is given by ओमेगा स्क्वायर r. देखो इसको ऐसे भी लिख सकते हैं, ओमेगा इंटू ओमेगा r. What is r omega? It is v. It is v. So the normal acceleration can be written as omega v, or it can also be written as, if I write v is equal to r omega, and omega can be written as v by r. So therefore omega square is v square by r square into r. So this gets cancelled, you get v square by r. So there are different forms of writing the normal acceleration, either v square by r, or omega square, or v omega. ठीक है सर, ठीक है सर, no problem. So we have to find out these type of acceleration. कैसे करेंगे सर? बहुत सिंपल वे में बताऊंगा सर. You differentiate this. What is dv by dt? This is a variable, this is a variable. क्या करेंगे? UV प्रिंसिपल. पहले इसको डिफरेंशिएट करो तो क्या होगा सर? इसको डिफरेंशिएट करेंगे तो d ओमेगा बाई dt क्रॉस r, UV प्रिंसिपल, दिस प्लस ओमेगा, इसको डिफरेंशिएट करना, इसको डिफरेंशिएट करना, इट विल बी dr by dt. Excellent sir. So you will get, what is dv by dt? It is the acceleration. What is dv by dt? It is acceleration. And what is d omega by dt? Alpha. Rate of change of angular velocity is angular acceleration. So this is alpha cross r plus v. What is rate of change of position or displacement? It is the velocity. It is v. देखो सर, it is the normal acceleration. अभी तो बताया, you can write, and this is the tangential acceleration. So the total acceleration vector is given by tangential and normal. खत्म सर. तो क्या करो आप? बहुत सिंपल क्वेश्चन है सर. ऑलरेडी मेरे पास अल्फा का वेक्टर है, पोजीशन, बिकॉज ही इज आस्किंग एक्सेलरेशन ऑफ ए, तो इट विल बी ए. Don't write alpha a omega a. Alpha and omega are for complete bodies. बहुत बढ़िया. तो ये आ गया सर. तो ऑलरेडी अल्फा वेक्टर इज नोन, already r vector is known. I'll calculate cross product. So with this cross product I get tangential acceleration. ठीक है. Already omega is known, already velocity at point A is known. I'll take already velocity at point A is known. इसका cross product I'll get the normal acceleration. खत्म सर. अब देखो, तो therefore I write here the acceleration is given by, देखो, so the total acceleration is given by tangential plus normal. Okay, the tangential acceleration अभी तो बताएं, what is the tangential acceleration? Alpha cross r. If I want the acceleration of A plus normal acceleration, what is normal acceleration? Omega cross VA. Of course these are all vectors, so ठीक है, even if I don't write, they are cross product है तो vector ही है. चलो, first I'll take this. What is this acceleration? So in examination he may be asking separately, what is the tangential acceleration, what is the normal acceleration? This is the tangential acceleration, so I write this as tangential. Then I calculate the normal acceleration. उसके बाद दोनों को ऐड करूंगा. Let's calculate tangential acceleration. देखो सर, alpha cross r, I j k. Already alpha is known. एक बार देखना सर, already alpha is known. Somewhere we have written, what is alpha? 4k. Alpha is 4k. So I is 0, j is 0, it is 4k. Because it is counterclockwise. RA is already known. एक बार देखना, RA 0.4i plus 0.3j. 0.4i plus 0.3j, there is no k. इसका क्रॉस प्रोडक्ट लीजिए सर. This will be this portion. Therefore, the tangential acceleration at point A stands for point A, is given by I into this minus, देखो this minus So it is 4 into 3 is 12. I think it is 1.2. Very good. Minus j into, suppose if I commit any mistakes, bata dena, 0 minus 4 into 3 is 12, 1.2. J gaya. So 0 minus it is 1.6. How 1.6? 0 ये वाला 4 into 4 is 16. 0.4 है तो 1.6, ये minus है सर, ठीक है सर. And k का 0 0. So you will get the tangential acceleration at A as minus 1.2 I cap minus of minus plus 1.6 j cap. So now let's calculate the normal acceleration. The normal acceleration again I j k, ठीक है सर. Omega is already known, minus 2k. So 0 0 minus 2. Already we have calculated velocity at A. Let's see the velocity vector. What is the velocity vector at A? 0.6 I minus 0.8 j. 0.6 I minus 0.8 j. There is no k. Let me check, sir. 0.6 I minus 0.8 j. See, my dear students, as I am explaining, that's why I am taking time. Otherwise, this can be solved in 2 minutes. Okay. Now, let's calculate this. I into 0 minus of minus ये तो plus होगा. 8 into 2 is 16. So 1.6. I repeat, 0 minus 0 minus of minus plus minus j into, आपको तो वेक्टर आता है ना सर, 0 minus of minus is plus, ये plus होगा. 6 2 is 12 and plus k into 0 0. ठीक है. So I get the normal acceleration as minus 1.6 I cap minus 1.2 j cap. This is, who knows, tomorrow in examination he may be asking separately tangential and normal accelerations. Who knows? ये तरीका है सर. तो we have calculated velocity at point A, we have calculated tangential acceleration, we have calculated normal acceleration. So what will be the total acceleration at point A? It is the summation of tangential and normal. Very good. Tangential minus 1.2 I plus 1.6 j. Sorry. Plus, this is tangential and normal, minus 1.6 I minus 1.2 j. I think you are getting I is minus 1.2 into 1.6 is 2.8 I. ठीक है सर, ये कितना आ रहा है सर? 1.6 minus 1.4 is 0.4. I think it is 0.4 j cap. And if you want the magnitude, under root of 2.8 square plus under root of minus 2.8 square plus 0.4 square, you get the answer. So the answer is minus 2.8 plus 0.4. It is the right. So many meter per second square. Why the answer is in meter per second square? Because the position vector is in meter. Very good, sir. This is also a good question. Very good. Now let's move to the next question. हाँ, ये वाला लीजिए सर. Please read this question. Of course, if the figure is not clear, I'll explain neatly. Do not worry at all. देखो. Please read the question before we proceed. Read the question. आराम से. Tension नहीं लेने का सर. Don't take any tension. Read the question properly. दिख रहा है सर? Can you see the question? मैं बताऊंगा सर. Don't worry. Motion of equilateral triangular plate. My dear students, there is a triangular plate. इसमें कलर कैसा फिल करते रे? समझ में नहीं आता, मुझे तो नहीं आता. आई डोंट नो हाउ टू फिल कलर. चलो कोई बात नहीं. ये कंप्लीटली एक सिंगल प्लेट है सर. ओके, लेट मी शो दिस एज दिस इज अ सिंगल प्लेट. This is a single plate. Next question is, sir, this is a single plate. Now, it is an equilateral triangle. So, each side is given as, my dear students, each side is given as B. This is B. This is B. This is also B. This length is B. And that is given as 0.2 meter. The each side is 0.2 meter. ठीक है sir. So this is a single plate. मतलब ये complete एक ही link है sir. This is a single link of equilateral triangle shape. हाँ, क्या बोला है सर? अच्छा क्वेश्चन है सर. The motion of equilateral triangular plate ABC in its plane is controlled by hydraulic cylinder D. There is a hydraulic cylinder here. Color change करेंगे सर. ठीक है. This is the hydraulic cylinder. ठीक है. Okay. D. This is the hydraulic cylinder D. Okay. If the piston rod in the cylinder, there is a piston rod in the cylinder which is reciprocating, okay, okay, it is moving up, the piston rod in the cylinder, and this rod is moving up. आराम से देखो सर. The end of this rod, this is the piston rod, this is the hydraulic cylinder. So from this hydraulic cylinder, the piston is moving up, and this piston is connected to this edge of this point of the equilateral triangle, and the piston is moving upwards. Yes. So as these two are connected, what will be the velocity of A? Same as the cylinder, sorry, piston का. तो कितना है सर? It is moving up at a this work to be taken is constant rate. So this is moving at a constant rate of 0.3 meter per second. I repeat, sir. There is a hydraulic cylinder. In this hydraulic cylinder, there is a piston. That piston is moving up. And as the piston is connected to the point A of this equilateral triangle, so this edge will move up. And when this edge is moving up, this is a single link. This is a single link. When this is moving up, what will be the motion of this? And this point B, my dear students, this point B is this point, ये वाला. So when this is moving up, obviously it will turn. So this will move to the right. It is in the horizontal slot. ये एक horizontal slot है, तो B is moving, तो it is VB. Very good, sirs. I repeat, sirs. ये B देखो, जब ये ऊपर, when it is moving up, this will move like this. ऐसा rotate होगा, ऐसा. So this, therefore, this is in this slot. So this moves to the right. ठीक है, sirs. क्या पूछा है सर? क्या बोला? During the point 3, during an interval of motion, calculate for the instant when this angle is theta, which is 30 degree. When this is 30 degree, the velocity of the center of the roller B, he is asking velocity of point B, ये वाला इधर से, and in the horizontal guide, this is the horizontal guide, and the angular velocity of CB, this is CB. So indirectly he is asking, please look at carefully, my dear students. बहुत अच्छा सवाल है सर ये. It's not that tough, I can say it's not that tough, but good question. Let me explain. एक सेकंड सर. हाँ, मैं फिगर दोबारा ड्रॉ करूंगा सर. डोंट वरी, आराम से कर लेंगे सर, आराम से कर लेंगे, कोई बात नहीं सर. This is the horizontal slot. Yes. In this slot, देखो एक्चुअली क्या हो रहा है सर. एक हम ट्रायंगुलर प्लेट लें. कलर कौन सा अच्छा रहेगा? क्या ग्रीन दिखेगा आपको? कोई बात नहीं सर, ग्रीन दिखता है शायद. चलिए देखते हैं सर, कोशिश करते हैं सर. Can you see? Okay. Yes. Right. And clearly, my dear students, clearly this angle is given. I'll take this color. I'm not used to this because smart board पे मैं generally नहीं लेता हूँ. This angle is theta and this is 30 degree. Okay. This point is moving. ये point क्या लिया था सर? A लिया था सर. And clearly he said this point A is moving up. My dear students, this point A is moving up. So let me write this as velocity VA, and that is given as 0.3 मीटर पर सेकंड. इज 0.3 करेक्ट है? एक बार चेक करते हैं सर. यस यस यस. ओके. Everyone knows if this is the point B, he is asking the velocity of this point B. तो कैसे करेंगे सर? So if this visualize करो, you just visualize the motion. My dear students, you just visualize the motion. तो I think if you visualize, so this completes, ये अगर ऊपर जा रहा है तो this has to move to the right. अरे because this is completely a single link, ये पूरा एक plate है. It is an equilateral triangular plate. So if this moves up, this will move to the right. This is our velocity VA. VB, I'm sorry. VB. ठीक है सर. This length is given. This is B. This is B. This is B. This length is given and it is given as 0.2 meter. ठीक है सर. And please note down that it is completely a single link. ये पूरा एक ही लिंक है सर. This is a single link. Equilateral triangular plate है ये. So as this is the first class on theory of machines, so I have taken some warm-up questions. Of course, these are not exactly warm-up. So अच्छे questions है सर. ये पूरा एक ही link है सर. This is a complete single link. ये वाला single link है सर. ठीक है. Now, and simultaneously you should practice with me also. Okay. Now, how do we proceed? How do we proceed? And this is B and it is 0.2. He said when the angle is, when this AB is making an angle theta with horizontal, what is the velocity of point B? And what is the angular velocity of this AB? AB बोला है, मतलब angular velocity तो ये complete एक ही लिंक का होता है. So कैसे करेंगे सर? बहुत सिंपल है. It is a rigid member. देखो AB. So let me take AB. बहुत easy है sir. Let me take AB. And we know that this angle is, देखो रे, what is this angle sir? 30 degree. Okay sir. And this is vertical, which is VA. This is point A. This is horizontal and this is point B and this is VB. Correct. Very simple, sir. As the member is rigid, there is no relative velocity along the length of the member. Its length is 0.2 meter. Along this, I have taken the portion of this. Along this, there should not be any relative velocity. ठीक है सर. अब देखो, now बहुत सिंपल सा कॉन्सेप्ट है सर. This is 90 degree. It is 30. This is 90. So this will be 60. Wonderful, sir. If this is 60, what about this, sir? What about this? Same line is extending. Same line is extending. If this is 60, this will also be 60 degree. Very good. Now, I will take the component of this परपेंडिकुलर टू दिस लिंक एंड अलोंग द लिंक. सो अगर आप देखेंगे ये VA है सर, and this angle is 60 degree. So what will be the component of this along the length of the link? Opposite perpendicular link के perpendicular तो opposite है तो sin आएगा, but मुझे ये चाहिए सर, तो it will be, if I want the velocity, this will be anyone. इस point का this I write it as VA cos 60. खत्म, टाटा बाय बाय गुड बाय गया. एंड सिमिलरली देखो इसका कंपोनेंट I will take, देखो one is perpendicular to the link, इसका perpendicular and other is parallel to the link. देखो link, तो ये कंपोनेंट चाहिए. ये अपोजिट ये वाला साइड, अरे यार ये भी नहीं आ रहा सर आपको. दिस इज VB. एक्चुअली आई शुड नॉट डू VA cos alpha is equal to VB cos beta. कितने क्वेश्चंस किए हम. ओके, आई एम रिजॉल्विंग दिस इनटू दिस कंपोनेंट, मेन वेलोसिटी इनटू टू कंपोनेंट्स. वन इज दिस कंपोनेंट, नहीं आ रहा सर आपको ये, तो मुझे ना ये 30 है. आई डोंट वांट दिस कंपोनेंट, आई वांट दिस कंपोनेंट, आई वांट दिस अलोंग द लेंथ. ये अपोजिट साइन है, तो ये क्या होगा VB cos 30. एंड यू नो वेरी वेल, एज द लिंक इज रिजिड लिंक, this velocity should be same. If the along the length of the link, if the velocities are different, it means there is no relative velocity. rigid नहीं हो सकता अगर relative velocity है. तो इसलिए now I write VA, the component of this along this is VA cos 30 is equal to the component of this along is ये B है ना, I'm sorry sir, ये VB है सर, ये VB cos 30 है, ये VB cos 30 should be equal to VA cos 60. ठीक है, already VA is given as 0.3, already VA. So therefore if you want VB, he is asking VB, a simple question, cos 60 by cos 30. Very good sirs. And VB will be equal to, what is VA? 0.3 into cos 60 is half, and 1 by cos 30 is root 3 by 2. So you will get the value of VB as root 3 by 2. तो कितना रहा? 0.3 divided by root 3. It is 0.1732 meter per second. क्या पूछा है सर? Now this part is over 0.1372. एक बार चेक करते हैं सर. ठीक है, वेलोसिटी आ गया सर. Now अब क्या करेंगे सर? He is asking the angular velocity of this member, that is triangular plate. कैसे करेंगे सर? कुछ हिंट दो. सिंपल वे में करना है सर. देखो सिंपल वे में करना है. देखो बहुत बढ़िया सर. लेट मी डू इट. So I am trying to do the question by using different methods. We have used, अब क्या करें, एक सेकेंड, we have used vector approach in previous questions. थोड़ा instantaneous center का मजा ले लेंगे सर. देख एक सेकेंड, लेट मी डू. क्या प्रॉब्लम है सर? एंजॉय करो लाइफ विथ कॉन्सेप्ट्स. हाँ जी सर. ओके सर. ओके सर. What is this angle, sir? This angle is 30. This length is given as 0.2. Now, there is a velocity in this direction vertically up. There is a velocity in this direction already. Just now we have calculated. ठीक है सर. अब देखो हाउ टू फाइंड द इंस्टेंटेनियस सेंटर ऑफ दिस. कुछ नहीं है, ये वेलोसिटी का एक परपेंडिकुलर ड्रॉ करो. ऑल दिस आई हैड एक्सप्लेन्ड इन आवर रेगुलर क्लास. इसका परपेंडिकुलर ड्रॉ करो इसके लिए. ठीक है सर. और ये हॉरिजॉन्टल को और एक परपेंडिकुलर ड्रॉ करो. ठीक है. Look at, we have drawn a perpendicular to this velocity. We have drawn perpendicular to this velocity. All this I had given. this is my instantaneous center. It's something like this plate is as if it is rotating about this, as if it is rotating about this, as if a complete plate. Yes. अब कितना सिंपल है सर. तो if I want the angular velocity of this complete member, ये वाला member, देखो बहुत सिंपल है सर, बहुत सिंपल. एक सेकंड, मैं दूसरा ले लूंगा. मैं कलर चेंज करता हूं. एक सेकंड सर, प्लीज bear with me. As if this complete member is rotating about this. तो क्या होगा सर? So you know what is this length. अगर ये velocity चाहिए तो क्या होगा सर? R omega, or you can also write, if you want this velocity it will be R omega. तो अगर my dear students देखो, as if this is completely rotating about this, as if, तो क्या होगा? As if. तो ये length can I calculate? Yes sir. This length, hypotenuse is 0.2, this is 0.2 and this is 30. तो can I calculate this वाला length? It will be 0.2 sin 30, which is nothing but 0.1. So this length will be 0.1 meter. And you know very well, अगर इस पॉइंट पे रोटेट हो रहा है तो what will be the tangential velocity? V is equal to R omega. ये मेरा R हो गया. तो VB is equal to R. What is R? 0.1. ये वाला लेंथ. V is as if this is rotating about this. As if. Hypothetically, I can assume that this complete system is rotating about this. So VB is equal to R omega. Very good. What is R? तो इसका tangential velocity R कितना है सर? 0.1. तो 0.1732 is equal to R into omega. तो ये कितना आ रहा है सर? I think you are getting 1.732 radian per second. Let me check sir. 1.732 कहां गया? Radian per second. Absolutely sir. Next question था sir. As if. Okay. ठीक है, चलो. Now let's move to the next question. कुछ अच्छा क्वेश्चन ले लेंगे सर. कहां गया? ये वाला लीजिए. Take this question. Again a good question. Take this question. Read properly. Come on, come on. एक बार पढ़ो. चलो. Now, develop general expressions for the instantaneous velocity and acceleration of point A. अच्छा. Of the square plate, there is a square plate. ठीक है sir. Okay. Which rotate about fixed axis. This is the fixed axis. ठीक है. Through point O. Take all variables to be positive. Okay, ठीक है. Then evaluate your expressions for theta is equal to 30, B is 0.2 and omega is 1.4 and alpha is क्या बोला है सर? Velocity and acceleration पूछा है. कोई बात नहीं सर. एक सेकेंड. This is a wonderful question sir. Let me explain what this question is all about. पहले हम क्वेश्चन को समझेंगे सर. First we'll try to understand the question. ठीक है सर. There is a square plate. Okay. The dimension of this is B. As it is square, all dimensions will be same. और एक बात है सर, he has given the axis, clearly the axis is given. तो मैं नीटली ड्रॉ करूंगा सर, लेट मी ड्रॉ। ब्लू दिखेगा, हाँ शायद ब्लू दिखेगा सर, कोई बात नहीं। आई थिंक यू कैन इजिली सी ब्लू, देखो ठीक है सर। This is x-axis, this is y-axis, and this is the origin O. ठीक है। This angle is given as, अच्छा क्वेश्चन है सर, this angle is given as theta. एक सेकंड सर, this angle is theta. If you see the direction of omega, it is clockwise. If you see the direction of alpha, it is anti-clockwise. What does it mean? ओमेगा मतलब ये प्लेट ऐसा घूम रहा है, दिस इज द स्क्वायर प्लेट, इट इज रोटेटिंग, but in the direction of motion omega is decreasing, that's why alpha value is opposite to omega. Okay, and values of alpha and beta and all are given, and theta, तो ये बोल रहा है when theta is equal to 30, if this angle is 30 and omega is 1.4 clockwise and alpha is 2.5 anti-clockwise and b is 0.2, what is the expression for develop the expression for acceleration and velocity? अच्छा क्वेश्चन है सर। Whenever you get a question on acceleration, it's my humble request, go for vector approach, थोड़ा फास्ट हो जाएगा सर। Just taking the cross product, you get tangential acceleration, you get normal acceleration, that's it sir. तो for that the first and foremost thing is, मेरे प्यारे दोस्तों, मेरे प्यारे विद्यार्थी, देखो what is the value of omega? It is 1.4 radian per second. See the direction of omega clockwise. Should I take minus or plus? देखो this is x axis y axis, जब ये घूम रहा है सब, when it is rotating like this, देखो when it is rotating in this xy plane, my omega will be about this axis, but it is going inside, clockwise means inside means minus, so therefore clockwise is minus, it is 1.4 k cap, and alpha is equal to, ये एंटी क्लॉकवाइज है सर, यू सी द डायरेक्शन 2.5, सो आई टेक इट एज प्लस। नाउ क्या पूछा है सर, whenever he asks you the velocity or acceleration, याद रखना not angular, अगर angular होता है, if it is angular it will be for the complete body, but he is not asking the angular acceleration or angle, they are given, he is asking velocity and acceleration at point A. देखो देखो, he is asking velocity and acceleration, my dear students, at point A. क्या करना सर? Now I'll tell you one golden point. What to do? Whenever he asks you velocity or acceleration at some point, मैं बहुत सिंपल वे में बताऊंगा सर। फर्स्ट राइट इट्स पोजीशन वेक्टर, जिस पॉइंट से वो घूम रहा है, तो कोऑर्डिनेट एक्सिस तो दे रखा है, ही हैज गिवन, तो राइट द पोजीशन वेक्टर ऑफ ए। वंस द पोजीशन वेक्टर ऑफ ए इज नोन, दैट इज आर ए, ओमेगा अल्फा आर नोन, who will stop you in calculating the velocity and acceleration? खत्म है सर। पहले पोजीशन वेक्टर लिखो, ऑलरेडी ओमेगा अल्फा आर गिवन, हाउ टू राइट द पोजीशन वेक्टर। यहां पे एक इंपॉर्टेंट चीज है सर, मैं बताऊंगा, इधर देखो रे, इसको थोड़ा हटा दूंगा, इसको थोड़ा हटा दूंगा, एक सेकंड, देखो कलर चेंज करेंगे, चलो कोई बात नहीं। मेरे प्यारे दोस्तों, ऑरिजिन से इस साइड पॉजिटिव होगा, इस साइड नेगेटिव एक्स होगा, ऑरिजिन से ऊपर पॉजिटिव वाई, नीचे नेगेटिव वाई, ऑब्वियसली ऑरिजिन से पॉइंट ए नीचे है, वो माइनस जे होगा, विल कैलकुलेट द वैल्यू फ्रॉम, देखो एक बार, एक सेकंड देखो मेरे प्यारे दोस्तों, इधर देखो सर, एक सेकंड, ज्योमेट्री से डरो मत, ज्योमेट्री से डरो मत आप। ठीक है सर, ओके। नाउ फ्रॉम द ऑरिजिन ये डिस्टेंस आ रहा है सर, पॉइंट ए का, फ्रॉम द ऑरिजिन पॉजिटिव साइड ही जा रहा है, लेकिन कैसे कैलकुलेट करें, एक सेकंड रुको। दिस इज 90 डिग्री, ये थीटा है, तो ये हो जाएगा आपका 90 माइनस थीटा, बिकॉज दिस इज अ ट्रायंगल, इन ए ट्रायंगल सम ऑफ द ऑल एंगल्स इज 180, सो ये 90 माइनस थीटा, बट ये स्क्वायर है, सो दिस इज वन साइड, दिस इज अनदर साइड, टोटल ये 90 है, तो अगर ये 90, इफ दिस इज 90 माइनस थीटा, दिस विल बी थीटा। ठीक है सर, बहुत बढ़िया, डोंट वरी, डोंट वरी, सो लेट मी डू इट वेरी नीटली। ठीक है सर, माय डियर स्टूडेंट्स, कैन आई कैलकुलेट दिस लेंथ, कलर तो चेंज करना ही पड़ता है सर, कैन आई कैलकुलेट दिस लेंथ, क्या होगा सर, एक बार देखो सर, दिस लेंथ विल बी इक्वल टू, ये बी है, दिस हाइपोटेन्यूस इज बी, ये वर्टिकल हॉरिजॉन्टल अपोजिट है, तो दिस विल बी बी साइन थीटा। प्यारे दोस्तों, दिस विल बी बी साइन थीटा। वन मोर थिंग, कैन आई कैलकुलेट, मेरे प्यारे दोस्तों, क्या बोला दोस्तों, बोला, कैन आई कैलकुलेट दिस लेंथ, दिस लेंथ इज बी, ये टोटल बी है, अरे बाबा बोलो एक बार, अरे बाबा, ये बी है, अगर ये बी है, अपोजिट इट विल बी साइन, तो ये टोटल लेंथ ये होगा कॉस, कॉस कॉस, सो दिस विल बी बी कॉस थीटा। ठीक है सर, दिस टोटल इज बी कॉस थीटा एंड दिस इज बी साइन थीटा। तो फ्रॉम द ऑरिजिन आई वांट पॉइंट ए का डिस्टेंस इतना है सर, आई रिपीट, फ्रॉम द ऑरिजिन, मेरे प्यारे दोस्तों, फ्रॉम द ऑरिजिन, फ्रॉम द ऑरिजिन, ये ऑरिजिन है, यहां से ये डिस्टेंस है सर, ये वाला डिस्टेंस, ये वाला, सो इट विल बी बी कॉस थीटा माइनस बी साइन थीटा, तो एक्स कोऑर्डिनेट बन गया पॉइंट ए का बी कॉस थीटा माइनस बी साइन थीटा, करेक्ट ना, दिस इज बी कॉस थीटा एंड दिस इज बी साइन थीटा, तो ये हो गया सर। तो सिमिलरली लेट मी कैलकुलेट y कोऑर्डिनेट, y कोऑर्डिनेट, तो दिस विल बी y कोऑर्डिनेट, दिस, तो a इज दिस प्लस दिस, तो व्हाट विल बी दिस लेंथ सर, ये वाला लेंथ क्या होगा, ये b है तो साइन है, तो ये b cos थीटा है। ठीक है, आई वांट दिस लेंथ, ये b है सर, हाइपोटेनस b है, ये साइन थीटा है, b साइन थीटा। So from the origin, how much is this sir? How much is this? How much is b cos theta plus sin theta? But origin से x is plus, okay? But ये distance क्या लेना चाहिए sir? I should take it as minus. So therefore y coordinate is minus of, because from the origin it is down, so it is b cos theta plus b sin theta. Excellent sir. Now let us put values of b is given, theta is given, let us put values. So I will get the position vector of a. Once the position vector of a is known, alpha is known, omega is known, rest is mechanical procedure. Let me write the position of a. Before the position of a is 𝑋𝐴𝐼 cap plus 𝑌𝐴𝐽 cap. This is माय डियर स्टूडेंट्स, क्या बोला मैं? माय डियर स्टूडेंट्स, एक्स ए, दिस इज वाई ए, ठीक है सर। लेट मी टेक बी कॉमन, एक सेकंड सर, इसको थोड़ा मैं निकाल देता हूं सर, आई नीड सम प्लेस टू वर्क ऑन, रिस्ट्रिक्शंस है फिर भी हम कोशिश करें। तो एक्स ए विल बी इक्वल टू, बी कॉमन ले लेना, ले लिए सर, व्हेन यू टेक बी कॉमन कॉस थीटा माइनस साइन थीटा, ठीक है। सो ऑलरेडी बी वैल्यू इज गिवन एज 0.2, cos theta is 30 degree and sin theta is sin 30 degree, ठीक है रे बाबा। So we can calculate how much is xa. Let me calculate, sir. Cos 30 is root 3 by 2. 1.732 minus 1 is 0.732 by 2. 0.732. So I think you are getting this as 0.0732 meter. एक बार चेक करता हूँ सर, कहाँ गया रे, कहाँ गया रे, I don't have these values. 0.0732, correct. Now let's calculate ये वाला सर, एक सेकंड, wait, let's calculate ya माइनस बी, ठीक है, cos theta plus sin theta. I have taken b common, y minus because from the origin it is down, so therefore ya is equal to minus b is 0.2, cos of theta is 30 because he has at 30 degree position, so it is sin 30. So if I calculate 1 point root 3 by 2, this is 1 by 2, root 3 plus 1 is 2.732 into 2 to गया 2.732 into 0.1. तो एक बार चेक कर लेना, डोंट थिंक दैट आई एम टेकिंग सो मच टाइम, जस्ट आपको समझाने के लिए आई एम टेकिंग टाइम, अदरवाइज इट विल बी वेरी इजी। कहाँ गया रे वो, कहाँ गया रे, पता नहीं यार, आई डोंट नो वेयर इज इट, कहाँ गया रे, एक सेकंड प्लीज। आई मिस्ड वन वेरी गुड क्वेश्चन सर, हाँ यही है, तो 0.2732 माइनस है, सो द पोजीशन ऑफ ए इज, वाई एक्सिस पॉजिटिव, ऑरिजिन से थोड़ा राइट है, तो ए इज कहां गए एक से 0.0732 आई कैप माइनस वाई ए इज 0.2732 जे कैप। वंस दिस इज नोन, क्या ये सही है सर? 0.0732 minus 0.2732. Now let's proceed. So we know, my dear students, आराम से, what is omega? I think omega is minus 1.4k, already given. Alpha is 2.5k, already given. ठीक है सर, and the position of A is 0.0732 I cap minus 0.2732 J cap, correct. Now you want the velocity, you know very well, I want the velocity of point A. What will be the velocity? Omega cross A, or I want the velocity of A, position vector of A. Don't write omega A. Omega is for the complete body, which is same. So if you want the velocity of A, it will be I J K omega. What is omega? K cap, like minus 1.4. Then ये वाला RA 0.0732, okay, minus 0.2732. There is no K here, 0. So I will calculate the velocity of A. How much is this, sir? So I into, हाँ जी sir, I into 0, माइनस होगा, माइनस और माइनस प्लस, लेकिन माइनस ही आएगा। ओके, तो 1.4 इंटू 0.2732। एक बार चेक करना सर, आई डोंट नो वेदर माई कैलकुलेशन इज करेक्ट और नॉट। ठीक है, आई इंटू दिस, माइनस माइनस प्लस माइनस ही आएगा। ठीक है, माइनस जे इंटू जे इंटू जीरो, माइनस ऑफ माइनस ये प्लस होगा, तो 1.4 इंटू 0.0732। So the velocity of A is given by minus 0.38248 I cap minus 0.10248 J cap। मैं चेक करता हूं सर, ये अनसॉल्व क्वेश्चन है, मेरियम क्रेक का 5.20 क्वेश्चन, आंसर देख रहा हूं सर, 5.20 का आंसर आई एम चेकिंग। 5.20 माइनस 0.382 आई कैप माइनस 0.1025 एग्जैक्टली। सो आंसर मैच हो रहा है सर, आंसर मैच हो रहा है, सो नो प्रॉब्लम। तो वेलोसिटी आ गया सर, लेट मी राइट ऑल वेक्टर्स। ओमेगा वेक्टर इज नोन, अल्फा वेक्टर इज नोन, आर ए वेक्टर इज नोन एंड वी ए वेक्टर इज नोन। अच्छा चल रहा है सर। माइनस 1.4 2.5, माइनस 1.4 2.5, let me check, minus 1.4 2.5 0.0732 I minus 0.2732 J, and velocity vector is just now minus 0.38248 minus 0.38248 minus 0.10248। How to calculate acceleration at point A? This acceleration has two components. I think I have told you. This acceleration has two components. What are those? Tangential and normal. कैसे? एक बार देखना. The velocity vector is given by omega cross r. Differentiate this. dVA by dt, which is nothing but acceleration of A, is equal to, you are differentiating, so UV principle. So first you differentiate this, d omega by dt, okay, into RA प्लस इसका डिफरेंशिएशन होगा यूवी प्रिंसिपल, इसका होगा तो एज इट इज इसको लिखना, अब इसको डिफरेंशिएट करना, डी आर ए बाई डी टी। तो व्हाट डू आई गेट? तो द एक्सेलरेशन ऑफ पॉइंट ए इज गिवन बाय, purposefully I am doing, already I have done this in the previous question, just माइंड में लाने के लिए। तो what is d omega by dt? अल्फा plus omega cross, what is the rate of change of position? R is position, which is displacement, change of position is displacement, displacement by time is velocity, that is v. This is your, yaad rakh lena sir, when in vector form it is very easy to calculate. What is this? It is the tangential acceleration. And what is this? It is the normal acceleration. So total acceleration has two components. So the tangential acceleration is given by alpha cross RA, and the normal acceleration is given by omega cross V. ठीक है सर। What I do is इसको हटा दूंगा because I need some place to work on, तो इसको मैं हटा दूंगा सर। ठीक है रे बाबा, वेरी गुड, ठीक है। थोड़ा कैलकुलेशन पार्ट इज वेरी इंपॉर्टेंट सर, चलो कोई बात नहीं, ठीक है। Now first let me, who knows, tomorrow he may be asking simply the tangential acceleration, simply the normal acceleration। देखो Now, let us calculate the tangential acceleration. देखो sir, the tangential acceleration. Alpha cross RA, tangential. मेरे प्यारे दोस्तों, क्या बोला? प्यारे दोस्तों बोला. Very good students of India. So tangential. Alpha cross RA. So it is 𝐼𝐗𝐾 alpha. What is alpha? 002.5 K cap RA. What is RA? 0.0732 minus 0.2732. This is 0. There is no K. I think it is correct. ना एक बार देख लेना क्या ये सही है या गलत है. 0.0732 minus 0.273. Yes. Let us calculate tangential. I into एक काम करते हैं सर, थोड़ा एक काम करता हूं सर, थोड़ा इसको हटा देंगे सर, इसको भी हटा देंगे. It is 0.0732 and this is minus 0.2732 and इसको थोड़ा इधर लिखेंगे. K ये तो कितना था सर, ये अल्फा टी, अल्फा मींस 2.5 और K का 0 है. सॉरी हंसेंगे लोग हमें देखकर. A tangential is alpha cross A. Alpha is 2.5 and क्या है alpha RA. What is RA? Yes. अब कैलकुलेट करो. Let's calculate the tangential acceleration at point A. I into 0 minus of minus plus होगा. So 2.5 into 0.2732. It is 0 minus of minus plus. माइनस J इंटू 0 माइनस आएगा ये 2.5 इंटू 0.0732 0.183. So the tangential acceleration of point A is given by 0.683 I cap minus of minus plus 0.183 J cap. This is the acceleration. Which acceleration? It is the tangential acceleration. But is the answer complete? No. I need to calculate the normal acceleration. How do I calculate normal acceleration? सुनो कहाँ लिखे सर? वेक्टर तो लिखेंगे पहले. The normal acceleration is 𝐼𝐗𝐾. इसको लिखेंगे normal acceleration. 𝐼𝐗𝐾. ओमेगा क्रॉस आर, ओमेगा 0 minus 1.4. Omega normal is omega cross V, velocity vector V. What is V? Minus 0.38248. This is minus 0.10248 and there is no K. ठीक है सर. लेट मी इरेज ऑल दिस. इसको मैं थोड़ा निकाल दूंगा सर. काढून टाका बोलते हैं मराठी में इसको. काढून टाका. इसको भी काढून टाका. इसको भी काढून टाका. इसको भी काढून टाका. इसको काढून टाका. लेट मी इरेज. एंड व्हाट इज दिस एक्सेलरेशन सर? इट इज द नॉर्मल एक्सेलरेशन. कैलकुलेट करो. I इंटू ये तो 0 हो जाएगा, ये माइनस ऑफ माइनस प्लस, लेकिन ये ऊपर माइनस है. माइनस 1.4 इंटू 0.10248 0.143472. एक सेकंड. I इंटू दिस माइनस okay. minus j into 0, again minus 1.4 into 0.3. See, you should do it along with me. If you are simply depending on me, you will never learn. I'm telling you, minus j into 1.4 into 0.38248. तो ये आ रहा है 0.53472. So this is the normal acceleration and this is the tangential acceleration. I want the total. So what should I do? So if you want the total acceleration, just add. My dear students, just add both. So the total acceleration is given by 0.683, 0.683 तो प्लस है, I का कोएफिशिएंट क्या है, माइनस है, तो माइनस 0.143472 I कैप, यस, प्लस ये क्या है सर, माइनस ऑफ माइनस प्लस होगा सर, ये प्लस 0.53472, ये भी प्लस है जे का 0.183 जे कैप. तो व्हाट डू आई गेट, 0.683 minus 0.143472. तो ये आ रहा है सर द टोटल एक्सेलरेशन एट पॉइंट ए 0.53953 आई कैप प्लस 0.53472 प्लस 0.183. तो ये आ रहा है पॉइंट, आई डोंट नो वेदर इट इज राइट और रॉन्ग, एक बार मैं आंसर चेक करने तक समझ में नहीं आया. 5.20 unsolved question. 5.20, 0.54, yes, plus 0.718, exactly sir, we got the answer. So happy, we have not committed any calculation mistake. Wonderful sir. Let's see the last question. Okay sir, then I'll be doing some more questions in the next series. Let's take the last question. अच्छे क्वेश्चंस किए सर हम. रीड द क्वेश्चन. आई थिंक द फिगर इज नॉट क्लियर, बट एनीवे मैं आपको फिगर ड्रॉ करके दिखाऊंगा सर. डोंट वरी, डोंट वरी. आई थिंक द फिगर इज नॉट क्लियर. चलो कोशिश करेंगे सर, डोंट वरी. द पिनियन ए ऑफ द हॉइस्ट मोटर, दिस इज द हॉइस्ट. देखो ये हॉइस्ट कर रहा है सर, ये देयर इज अ पिनियन. देखो पिनियन ए, लेट मी चेंज द कलर. अच्छा क्वेश्चन है सर, दिस इज अ वेरी गुड क्वेश्चन. यहां पे एक छोटा सा गियर है, छोटे गियर को मैं बोल रहा हूं ये पिनियन बोल रहा हूं सर. ठीक है, दिस इज पिनियन ए. द पिनियन ए of the hoist motor drives gear B. This is gear B. Wait. अच्छा क्वेश्चन है इसको. ये मैकेनिक्स और रेक्टिलिनियर ट्रांसलेशन विद कांस्टेंट एक्सेलरेशन जो हम मैकेनिक्स में पढ़े थे, v स्क्वायर माइनस u स्क्वायर इज इक्वल टू 2as, उस कॉन्सेप्ट्स के साथ साथ कुछ लिंक्ड क्वेश्चन है सर. ऑल दीज क्वेश्चंस आई हैव टेकन फ्रॉम मेरियम क्रेग बिकॉज गेट से बहुत सारे क्वेश्चंस उसी बुक से आ रहे हैं सर. ठीक है, दिस इज गियर बी. ठीक है सर. नाउ द पिनियन ए of the hoist motor drives gear B which is attached to the hoisting drum. देखो एक ड्रम है सर, ये वाला ड्रम. ठीक है सर, यहां पे वी आर रेजिंग वेट्स. ठीक है सर, दिस इज द लोड, L stands for load and this is raised. ठीक है सर. Now the load L is lifted from rest. This is very important. From rest position and acquires a upward velocity of 2 meter per second. This load is acquiring a velocity of 2 meter per second. Okay, initially it is starting from rest and it is acquiring a velocity of 2 meter in the vertical. in a vertical rise of 0.8 meter. So originally the load was somewhere here, and the load is rising through a distance of 0.8 meter. From bottom, it is lifted by this. So you know very well, when it is lifted, initially it was at rest, now it is lifted. So when it is at a position of 0.8 meter, the velocity of this load, देखो velocity is 2 meter per second, and this is connected to the drum. ठीक है, अब ये घूम रहा है सर. गेस मारो ये किस डायरेक्शन में रोटेट होगा सर? ये एंटी क्लॉकवाइज होगा सर, ये एंटी क्लॉकवाइज होगा, बिकॉज द लोड इज लिफ्टेड अप. व्हेन द लोड इज लिफ्टेड अप, इट हैज टू रोटेट एंटी क्लॉकवाइज, देन ओनली द लोड इज लिफ्टेड. ठीक है सर. नाउ हाँ, with a constant acceleration, हाँ, this word is also important. The load is lifted with a constant acceleration. मतलब ये load, ये धागा, ये जो rope है ना, it is undergoing rectilinear translation with a constant acceleration. So can I apply equations of motion? S is equal to ut plus half at square, v is equal to u plus at, v square minus u square. Yes, they are applicable only when the acceleration is constant. तो यहाँ पे hint दिया सर, constant acceleration. As the load passes this position, मतलब ये वाला position, when it lifted through 0.8 meters, okay, compute the acceleration of point C on the cable. यहाँ का acceleration पूछा है सर. Point C on the cable in contact with the drum, angular velocity and angular acceleration. बहुत बढ़िया सर. ठीक है, अब देखो सर, आराम से कर लेंगे. So what I do is, my dear students, can I calculate the acceleration of this जो rope जो string है, string के attached ये पूरा system है इसका, along with there is a gear B, ये complete system का, I'll calculate the angular velocity. एक सेकंड रुको. तो क्या मैं इस पॉइंट का एक्सेलरेशन कैलकुलेट कर सकता हूं सर? क्या नहीं कैलकुलेट? इधर देखो सर, लेट मी ट्राई टू कैलकुलेट. कलर चेंज करेंगे सर. हाँ, v स्क्वायर minus u square is equal to 2as. Finally, after some time, what velocity it has achieved, sir? 2 meter per second. ये वाला कितना velocity? Let us find out the acceleration with which the load is lifted. So, what is v? 2 square. After some time, it has achieved a velocity of 2. What is the initial velocity? It is starting from rest. The initial velocity is 0, is equal to 2 into acceleration. What is the displacement? Displacement from here to here, the displacement is 0.8 meter. देखो कितने concepts linked है sir. So with this information, he used one word, constant acceleration. If the acceleration is not constant, I am not supposed to use this equation. चलो, let's find out the acceleration. तो 4 ये आएगा, 2 square is 4 minus 4 is equal to 8 into 2 is 16a. So you will get 4 by 1.6. So I think the acceleration is कितना आ रहा है सर? 2.5 meter per second square. ठीक है सर. And my dear students, if there is no slip between the drum and the cable, what will be the acceleration of this? ये तो tangential है सर, ये तो tangential of this point C same होगा सर. अगर slip नहीं हो रहा, you will get the same acceleration. बहुत बढ़िया सर. Wonderful sir. And one more thing, मेरे प्यारे दोस्तों, इधर देखो, मैं कुछ अच्छा ऐसा बताऊंगा सर. ये ड्रम है, इसके अंदर एक मतलब ये गियर है सर. ये कौन सा गियर है सर? दिस इज गियर बी. दिस रेडियस इज गिवन. मैं थोड़ा रफ फिगर ड्रॉ, चलो अच्छा ही ड्रॉ करेंगे सर. आप खुश नहीं है, खुश करेंगे आपको. ओके, देखो सर्कल ले लेंगे, देखते हैं शेप्स है या नहीं है. शेप्स नहीं दिख रहे हैं ना रे, सर्कल ही नहीं दिख रहा इसमें. हाँ है सर. बहुत बढ़िया. ठीक है. नाउ ऑन दिस मैं कोशिश कर रहा हूं सर, लाइक आराम से। यू नो माय डियर स्टूडेंट्स, आराम से देखना सर, टेंशन में मत आना। क्या ना इससे दिस इज द टेंजेंशियल वेलोसिटी। देखो व्हाट इज द वेलोसिटी, ये ऊपर जा रहा है 2 मीटर पर सेकेंड, मतलब यहां का द टेंजेंशियल वेलोसिटी इज 2 मीटर पर सेकेंड। ये ऊपर ऐसा घूम रहा है, एंटी ऊपर जा रहा है 2 मीटर पर सेकेंड। एंड यू नो वेरी वेल इसका रेडियस दे रखा है सर, ये कंप्लीट रेडियस, ये टोटल रेडियस, सॉरी डायमीटर इज गिवन, दिस टोटल डायमीटर इज गिवन, कंफ्यूज मत होना, दिस डायमीटर इज डिफरेंट, दिस गियर, यहां पे गियर है सर, बी केयरफुल, मैं बताता हूं सर। डोंट वरी लेट मी डू इट। ठीक है सर, ये बिगर डायमीटर इज गिवन एज 800 mm, और ये वाला छोटा डायमीटर दिया है, एक सेकंड कलर चेंज करता हूं ताकि आपको समझ में आए। ये वाला गियर वाला कितना दिया सर, गियर वाला एक बार देखते हैं, 600, यस, दिस इज गिवन एज, ये वाला दिया है 600 mm। प्लीज नोट डाउन दैट दिस गियर इज इन कॉन्टैक्ट विथ अनदर गियर, तो कैन आई कैलकुलेट वंस द टेंजेंशियल वेलोसिटी इज नोन, और ये ड्रम और इसमें कोई स्लिप नहीं हो रहा, तो ये पूरा सिस्टम का एंगुलर वेलोसिटी कैन आई कैलकुलेट, यस सर। So you know this complete radius is 800 mm. Sorry, diameter is 800 mm. So what will be the radius? What will be the radius, sir? Radius is 400 mm. तो क्या मैं ये radius है, this is 400 mm. तो क्या मैं कैलकुलेट ओमेगा ऑफ दिस कंप्लीट सिस्टम, ये वाला सिस्टम, v, दिस इज द टेंजेंशियल वेलोसिटी, v is equal to r omega. This is the tangential velocity. There is no slip between this drum as well as this string. So therefore, तो इसका टेंजेंशियल वेलोसिटी और इसका सेम होगा सर, दे आर एट द पॉइंट ऑफ कॉन्टैक्ट, तो v इज इक्वल टू r ओमेगा। v कितना है सर, 2 है, रेडियस ध्यान से सुनो। सो ये कंप्लीट सिस्टम का आई एम कैलकुलेटिंग ओमेगा, द कंप्लीट डायमीटर इज, दिस इज ऑन द डायमीटर, देखो कंफ्यूज मत होना, गियर हैज नथिंग टू डू विद दिस, तो ये दिस डायमीटर ऑफ दिस ड्रम, कंप्लीट ड्रम इज 800, तो रेडियस कितना होगा 400, तो 400 कैन बी रिटन एज 0.4, v इज इक्वल टू r इंटू ओमेगा। ये कौन सा सिस्टम है सर, ये इट इज बी ना, या बी है, ये बी है सर, दिस इज कंप्लीट, आई एम टेकिंग इट एज बी, सो देयरफॉर बी, व्हाट इज ओमेगा बी, what is omega b? I think we can calculate 2 divided by 0.4, it is 5 radian per second. But he is not asking the omega of b, he is asking omega of a, pinion का omega पूछा है सर, and you know this is rotating in anti-clockwise direction, ध्यान से सुनिएगा सर। अब देखो, now I'll give you the beauty, एक सेकंड इसको हटा दूंगा सर, you will enjoy सर, इसको हटा देंगे सर, ये नहीं जा रहा सर, अरे पता नहीं ये नहीं जा रहा है सर, हे भगवान मुझे तो कुछ आता ही नहीं। एक सेकंड सर, हो गया डोंट वरी। तो हियर वी आर अटैचिंग, वी हैव अटैच्ड वन गियर, दोनों कांटेक्ट में, मेरे प्यारे दोस्तों में बोथ आर इन कांटेक्ट, तो यू नो यहां का टेंजेंशियल वेलोसिटी दोनों का सेम होना चाहिए सर, बिकॉज व्हेन दे आर इन कांटेक्ट, यस सर, तो क्या मैं लिख सकता हूं, द टेंजेंशियल वेलोसिटी इज आर ओमेगा, दिस रेडियस, ध्यान से सुनो सर, दिस रेडियस इज गिवन एज, ये वाला रेडियस दिया, डायमीटर इज 200, तो रेडियस इज 100, दिस रेडियस इज, ये वाला रेडियस इज 100 mm, एंड ये वाला रेडियस, सुनो सर इसको मैं हटा दूंगा सर, वेट, please note down that drum is not in contact, it is the gear, this radius is given as totally 600, तो ये 300 mm होगा सर रेडियस, एंड दिस इज टोटली 200, ये 100 होगा, तो इस पॉइंट ऑफ कांटेक्ट पे द टेंजेंशियल वेलोसिटी सेम, बिकॉज पॉइंट ऑफ कांटेक्ट पे टेंजेंशियल वेलोसिटी सेम है, तो ये क्या होगा आर ओमेगा, आर इज इसका आर ओमेगा, इसका आर ओमेगा, आर इज 300, I will write this as omega b. This is b and this is a. So what will be the tangential velocity here? R omega. Iska R hai 100 and the omega of this is, let me write it as omega a, because at the point of contact देखो इस point पे the tangential velocity should be same. तो इसका होगा R omega इसका and इसका अगेन आर ओमेगा एट दिस पॉइंट. तो ये हो गया सर. अगर ये बिगर वन एंटी क्लॉकवाइज रोटेट हो रहा, ये पिनियन विल रोटेट इन क्लॉकवाइज डायरेक्शन. ही इज आस्किंग ओमेगा ऑफ दिस. ओमेगा इसका ओमेगा पूछा है सर पिनियन का. क्या करेंगे सर? तो आई थिंक this is gone, both are in mm. तो omega a is 3 times omega b. तो omega a is 3 times, it is 5. I think it is 15 radian per second. Let me check sir. Let me check sir. क्या बोला मैं? Let me check sir बोला. एक सेकंड. कहां गया रे? कहां गया रे? Yeah, 15 radian per second is absolutely correct sir. 15 radian per second is absolutely correct. लेकिन in which direction? If this is rotating in anti-clockwise, this will rotate in clockwise direction. बहुत बढ़िया sir. Now what I do is I will bring some more quality questions sir. Already I have selected. So I will take some more questions sir. Some more beautiful questions. Let me discuss. बहुत अच्छे क्वेश्चंस हम डिस्कस करेंगे सर. बट वन इंपॉर्टेंट पॉइंट ऑफ दिस कंप्लीट सीरीज इज व्हेन आई एम कैलकुलेटिंग इन क्लास you should also take calculator and you should do it. In this question he asks what is omega of this pinion A. Very simple sir. कैसे अप्रोच किए सर? यहां से we calculated acceleration. From acceleration and from v अगर I think he also asked, देखो देखो क्या पूछा है? Angular acceleration and angular velocity of A. Already we have calculated angular velocity of A, angular acceleration. So at that point of contact, the tangential acceleration R alpha for A and R alpha for B should be same. RER. Very simple, sir. What is the radius of A? 100. What is alpha of A? कहां गए रे? What is alpha of A? I don't know. Is equal to what is the radius of B? It is 300. Okay, and alpha of B, sir. Previously omega of B was known, so we calculated omega of A. यहां पे alpha of A is not known. कैसे कैलकुलेट करेंगे? बोलो सर. हिंट दो. V is equal to U plus A. This is your assignment. In the next question, I'll discuss this. V is equal to U plus AT कैसा है? Omega is equal to omega naught plus alpha T. Or use that equation. And I want the angle. I have given you the hint. And you should calculate the value. Alpha B को calculate करो. Once that is known, you can calculate alpha A. करेंगे? This is your assignment, so I'll discuss in the next class. And let me check what answer you are getting. एक second. You should get an answer of एक second, sirs. Wait. कहाँ गए रे? कहाँ गया? 18.75. 18.75 करो सर. लेकिन यहां पे मेरे प्यारे दोस्तों, आई गॉट दिस एज ओमेगा ए एज 5. आई वांट अल्फा ए. कैसे करेंगे सर? इधर देखो. A इज इक्वल टू आर अल्फा टेंजेंशियल एक्सेलरेशन. हमने जो कैलकुलेट किया, इधर देखो सर, ये कौन सा एक्सेलरेशन होगा सर? इसके लिए लीनियर है, लेकिन इसके लिए क्या होगा सर? ये टेंजेंशियल है सर. अरे इसके लिए लीनियर है और इस ड्रम के लिए क्या होगा? टेंजेंशियल एक्सेलरेशन. बट टेंजेंशियल एक्सेलरेशन इज आर अल्फा. यू नो, ध्यान से सुनो, ऑलरेडी द टेंजेंशियल एक्सेलरेशन अभी तो कैलकुलेट किए. आई थिंक वी कैलकुलेटेड एक्सेलरेशन आ गया ना रे. ये इसका लीनियर है तो इसका टेंजेंशियल एक्सेलरेशन. अगर बिकॉज ऑन दिस, इसके लिए लीनियर है, इसके लिए लीनियर, तो इसके लिए ये होगा टेंजेंशियल, बिकॉज देयर इज नो स्लिप, तो इसका लीनियर एक्सेलरेशन, इसका टेंजेंशियल एक्सेलरेशन सेम होगा. व्हाट इज द टेंजेंशियल एक्सेलरेशन सर? 2.5. 2.5. आई रिपीट सर, इट इज लीनियर है, तो इसका लीनियर एक्सेलरेशन इज 2.5. ऑलरेडी वी हैव कैलकुलेटेड बाय यूजिंग v स्क्वायर माइनस u स्क्वायर इज इक्वल टू 2as. तो इसका लीनियर एंड इट इज रैप्ड ऑन दिस, देयर इज नो स्लिप, तो इसका लीनियर इसके लिए टेंजेंशियली है, बिकॉज इट इज बिकमिंग लाइक दिस, ये तो टेंजेंशियल है, तो दिस 2.5 इज लीनियर फॉर दिस, 2.5 इज टेंजेंशियल फॉर दिस. टेंजेंशियल इज r अल्फा. ये कौन सा सिस्टम है सर? ये this is B system, this is B system, and the radius is diameter is 400 mm, तो radius diameter is 800, radius is 400. तो देखो AT is 2.5, radius is 0.4, and this is alpha of B. तो कितना आ रहा है सर? 2.5 by 0.4. 2.5 by 0.4. I think you are getting alpha B as 6.25. Once alpha is known, alpha B 6.25, तो ये 2 ones 2 3s, alpha A will be equal to 3 into 6.25, तो कितना आ रहा है सर? into 3, and this is 18.75 रेडियन पर सेकंड स्क्वायर. मैं ही कैलकुलेट किया सर, I asked you to do and I have done. ठीक है, so kindly please leave comments, एंड प्लीज मेरा रिक्वेस्ट है, कमेंट्स लीव करो, अच्छा चल रहा है तो आई विल कंटिन्यू. ठीक है, सो थैंक यू माय डियर स्टूडेंट्स, एंड आई विल कम अप विथ सम मोर ब्यूटीफुल क्वेश्चंस ऑन थ्योरी ऑफ मशीन्स. सो मेरा तो प्लान है कि थ्योरी ऑफ मशीन्स, मशीन डिजाइन, देन मैथमेटिक्स एंड स्ट्रेंथ ऑफ मेटल्स, ये पहले करने का. ठीक है, चलो बाय बाय, थैंक यू.